All right, welcome back everyone. So we're gonna continue on from last video straight away where we looked at exponential equations. Now we're gonna look at exponential functions and actually looking at how these are graphed. So the most simple or the simplest exponential function has the form y equals a to the power of x, where a is greater than 0 and a cannot be equal to 1. Okay, otherwise we just get a straight line. So an example here, y equals 3 to the power of x. So I've done a little table. So I've got all my x values and the corresponding y values. So if you substitute in x equals -2, 3 to the power of -2, remember negative indices 1/9. So one thing you'll notice is a slight pattern. So mine's a little slightly off symmetry. So 0 to 1. But if I have x equals 1, y equals 3. If I have x equals -1, y equals 1/3. Okay? So one thing you'll notice is that it will never touch the x-axis in this case. So there is always a horizontal asymptote. And unless the exponential function is vertically translated, which we'll look at in a minute, it will pass through y equals 1. All right? So remember when we're drawing functions or drawing graphs, really important, nice scale on x and y, labeling x and y, and labeling our function, super important. So the general exponential function equation looks something like this. So y equals k, so some variable k, times by a to the power of x, take away c, plus b, where a cannot equal 0, a has to be greater than 1, and k cannot equal 0 either. All right? So a controls how steeply the graph increases and decreases. C will control the horizontal translation, so moving left to right. B controls the vertical translation, so up and down. And the equation of the horizontal asymptote is y equals b. So this value for b is the value where we have our horizontal asymptote and the function will never touch. All right, so just a few little key features. So if you're looking at describing exponential functions, if your k is greater than 0 and a is greater than 1, it is increasing and looks like this. If k is greater than 0 and a is between 0 and 1, it is decreasing and looks like this. If k is less than 0 or a is greater than 1, it is decreasing, but our graph looks like this. And finally, if k is less than 0 and a is between 0 and 1, it is increasing, but our graph will look like this. So there are three things we need to graph exponential functions. So we need the horizontal asymptote, the y-intercept, and two other points. All right, so graph 2 times by 2 to the power of x plus 3. All right, let's first break down what we've got. So we've got k, we've got a, we don't have a c, and we have a b. So remember, horizontal asymptote is y equals b, therefore y equals +3. All right, y-intercept is when x equals 0. So when I substitute x equals 0, we've got 2 to the power of 0, which gives me 1. 2 times 1 is 2, plus 3 is 5. And then we need some other points. So I'm going to choose x equals 2, which will give me y equals, so 2 to the power of 2 is 4. 2 times 4 is 8, plus 3 is 11. And x equals 3, which will give me, y equals 2 to the power of 3 is 8, times by 2 is 16, plus 3 is 19. All right, so we have a fair bit of information there that we can use. All right, so horizontal asymptotes at 3. So what I'm going to do first is I'm actually going to draw my scale, my axes. All right, so remember, label your axes, y and x. Origin. So my max y is going to be 19, so I'm going to go up maybe 5, 10, 15 to 20, and then x equals 3, so if we go 1, 2, 3. All right, so nice clean scale This is going to showcase all of our information. All right, y-intercept is 5, so it actually hits through there. I might actually move it over just a little bit, just so we can get a glimpse of what's happening on that negative x-axis. So I'm going to actually extend out my x-axis just like this, just so we can have a bit of a look at what's happening over there. So this is -1. All right, horizontal asymptote is what? 3. So what we need to do, we need to draw a little line through 3, which is about here on our scale. All right, so our graph will not touch or go past this point here. All right, so then we have the point 211, so which is about there, and 319, which is about there. So now all we're doing is connecting the dots, just like that. All right, and finally, last but not least, we have to label our function. Just like that. And that is how we graph these. All right, hopefully that helps. We will catch you guys in the next video.